Okay, now we've got those changes. We're just going to slide on here. And we got PreCalc section 5.5, law of sines. After this, I'll be able to understand and use the law of sines to solve triangles, given angle, angle side, or angle side angle. Now these two are nice and clean. There's really no issue with them. Okay, the problem comes in when we're given a side angle. When we have two sides and an angle provided, that's when we start having an issue. Okay, and then tomorrow we'll look at apply the law of sines in real world applications. But when we're doing this today, this is the law of sines. You may have seen this in Algebra 2. Okay, I think they actually showed it in Algebra 2. Yes, recall from people, nods, no, maybes. I got head shakes. Okay, well here's the deal. When I'm finding angles, I want to use this relationship. They're ratios. Okay, the sine of the angle is the same, to the side opposite that angle is the same as the sine of the angle of the other angles in their sides, appropriate side opposites. But if I'm ever going to find the sides, I'm going to do the reciprocal. So I want to use this. So flip them upside down because the working the algebra becomes easier. Okay, I mean, just straight up and being forward about it. Okay, now part of this today is I want to make sure that you're aware when you find something, just don't find it, be very clear about what you're finding, showing the work to find something. Okay, so when we're doing this today, before we even start, your calculator should be in degree mode. Okay, I would even write this in notes because people, go through this and then they start getting really funky numbers. So make sure you're familiar with going to your degree mode. Remember, we've been in radians a lot, so probably it's in radian mode right now. Okay, so this checker out as we're going. I had to check a couple times with me when I was doing my stuff today just to make sure I didn't screw things up. And how we use this. A little review. Do you guys remember triangle sum theorem? The three angles of the triangle, the inside version, all 180 degrees. We're going to be using that as well. We're also going to be using it, and in an appropriate time, we'll talk about isosceles triangle theorem, which is when I know that two sides of a triangle are congruent, then the base angles are congruent. And we're going to be using that as well to make things go a little bit easier, more efficiently when we find some pieces of our triangle. Keep in mind, we're solving triangles. Notice I said triangles. Before we are solving right triangles, bless you. Okay, so you got to keep in mind the stuff we're about to learn is all about finding missing pieces of triangles. Okay, it's all algebra, but it's trig driven, but it's the friendly trig stuff that you've seen before. We're using that for calculations. So really what it comes down to, I'm going to find my measure of angle C. So find measure of angle C. And the measure of angle C here is going to be 180 minus the sum of 36 and 48. Okay, because that's the measure of angle A and angle B. So I'm going to subtract those out, and I'm being pretty particular about how I'm doing it so everybody knows what's going on. And if you notice that I had fat fingeritis, let me know, okay, as we get going here, because I'm trying to make sure that this goes as smooth as possible. So I did all my calculations beforehand. Okay, I'm going to get a little bit more space here. Maybe. Yeah, there we go. Okay, so the first thing I'm going to do is I've got my angle C, so I've got that done. Okay, and I'm just going to mark it on the triangle just to make sure I know I'm done. Remember, there are 6 pieces I've got to find, 3 angles, 3 sides, okay, as we go through. And this one's kind of nice because, the way this is set up, we just got this one triangle. We're going to talk about when I have 2 triangles coming up here. To find B, if I'm going to find B, it's a side, and I'm going to find C as a side. Now, to find B, and use these lowercase, uppercase, it's pretty straight up as far as, the expectation of notation. I'm going to find B, and I'm going to flip it. Okay, I'm going to use A And when I do this find B, I'm going to find B, and I already know the sine of B, it's 48. And A is 8, 8 sine of 48 over sine of A, which is 36. Now, keep in mind what I just did. I just did a cross multiplication, except I knew that B sine A was going to have sine of A divide on the other side. So what I want you guys to know is the reason why I'm flipping this is if I'm just going to find B here, I just multiply what's in the denominator here up here, and that's it. That's the only move I have to do algebraically because it'll work. Okay, I'm just multiplying by sine of B on both sides. Okay, so now I'm going to pop that in my calculator, and my B value, interesting, my B value is 10.115. Okay, and maybe I should get my C boxed in there too, so you guys know that I found C. Okay, now on my other side, my find C, actually I'm going to have you guys find C. Check it out, C, sine of C, equal, and I'm going to use A sine of A again, because that's a nice solid relationship. I'm just going to go with it. You guys, go, your turn, find C. Okay, so here's the deal. We've got this going on with C, and keep in mind, you know, it was like a miracle what I did with sine B up here. I just multiplied by sine B on both sides. That's how I got that sine B of 48. Remember, B is 48 degrees. That's where that sine of B comes from. And I'm going to do the same thing on this other side. We already know that C is 96, so I'm just going to pop it in there. That C 96 is equal to A, which, you know, A is 8, and sine of A, sine of 36. Now I'm going to multiply both sides by sine of 96, and C is equal to 8 sine of 96 over sine of 36. Okay, and I'm just going to pop it in my calculator, and I get 13.536. How'd you all do? Was it okay? Any questions on anything that I did, anything funky? That's straight out, and keep in mind, this was angle side. Okay, I was given two angles and a side. Okay, and people are like, what? Okay, provided two angles and a side, I can find the missing pieces of the triangle. Now, this next section is talking about the ambiguous case when I'm given two sides and an angle. Okay, and the ambiguous case in this, let's see if we can get this with a pointer here. So we can just have a little cursor there going through there. That's going to go great. Let's see how that works. And go back here. All right. So here it is. In the side-side angle case, that is two sides in the non-inclusive angle. That non-inclusive angle. If I'm given this side, and this is the non-inclusive angle. Okay. That's the situation we're going to be talking about. Okay. It's the ambiguous case because this information does not necessarily make a unique triangle and possibly not even a triangle at all. In fact, depending on the proportion of the side lengths and the angle, it could be 0, 1, or 2 triangles. Here's a visual on why. Okay. Now, first of all, as we're going through, A could be much smaller than B, and people are wondering, how would you know this situation would occur? Well, keep in mind that opposite hypotenuse would come in here because, say that's the height there. I can find that length if I just use the idea that it's going to be a right triangle there. So I've got opposite hypotenuse. Well, if I'm looking at something opposite hypotenuse and I've got sine of angle A, and that's going to equal A over B in this case, okay? B sine of A is my A length, or in this case, what I'm really looking for is height. Okay, because that'll be the height of that triangle. If this height is more than angle A, I know it's going to look like that picture. Okay, it's not going to reach the bottom. Say if this height was 9 and angle A was 5. Well, it's not going to make a triangle, so I'll say, hey, it doesn't make a triangle at all as I go through. This is where it's exactly this length. You know, H and A are the same value. Okay, if I find that length h, and a would be the same value, it's coming straight through. Now, this is the situation we're concerned about. When a is smaller than b, excuse me, when a is smaller than b and a is longer than h, there's two possibilities of me placing that side, okay, in a triangle sketch. All right, there's two possibilities, and that's what we're trying to work on today. If A is much larger than B, there's only one way I can put it in, okay? So these are the big three. It's not going to make a triangle because it won't reach, okay? Here, it's a right triangle because it's exactly, that's the exact length from C down to that side AB. It's possible that it could be two different triangles because A is bigger than, this pink A is bigger than the height, and therefore it can be placed here or be placed there. Or when this value A is much larger than this given angle, A, in this case, much larger than B, then it's just gonna make one triangle. All right, so we're gonna be stepping through and we're gonna be talking about angle B throughout the rest of this. Okay, so when we're doing this, they're talking about the acute cases. Now we hit this, it's not gonna make a triangle, it's a right triangle, it's two different types of triangles because B is bigger than the height. Okay, and we got case 4 where B is much bigger than A, and case 5 where B is still, or B is equal to A, where it's going to be an isosceles, and then B is much bigger than A. It's just one solution. These are the things that you're going to work on and practice recognizing as we go through. So let's going on to this next page. We got case 6 and case 7 and case 8. These are all obtuse. And when I got an obtuse situation, I don't have to check for the height. I got to check for the height in the acute situation. In the obtuse situation, the side opposite B must be, the side opposite this angle, the provided angle, must be bigger, okay, than this other side, provided. And people are like, well, how do you make that decision? They'll give you a capital B and a small case A. Well, remember, or a small case B, excuse me, and that's this length coming across. This length for an obtuse triangle has to be bigger than this length. Otherwise, it's not going to make a triangle in the obtuse case. Okay, and that's what they're trying to get at here. If they're equal, B and A are the same length, it's not going to make a triangle because it's just sitting there from the hinge up. Okay, it's not going to work. So that side opposite the provided angle must be larger than the A side. Be in a habit when you're given an angle on two sides, side angle. We won't go angle side, by the way. We won't write that in the math book. I just thought I'd tell you. Okay, so it'll be side angle versus angle side. Okay, I know Olson, you're thinking about doing that. Okay, so here's the deal. B's got to be bigger than A for the obtuse situation to take hold. This is a table to kind of talk about, to reference what we just looked at, okay, as a brief summary, okay? Because of the B and A, B's less than A, B's equal to A, B's greater than A, and we're always talking about angle B, that's the reason why I had you change the letters in these example problems, okay? Not all the time will the angle be B and they'll change the angle. So the very last one, I changed it up. So you hopefully will pick up on the things we're supposed to know. But for right now, what I'd like you to do is look at A, B, and C and determine whether it's going to be one triangle, two triangles, or no triangles based on the information provided in the summary table, okay? It'll take about 7 minutes for us to do A, B, and C, okay? I want to debrief them after we do A, B, and C, and then I want you to do D, E, and F, okay? I find that if we are thinking about that summary table as we go through, it'll make it easier, okay? That's why I changed the letters. Okay, go ahead and give it a try. Do A, B, and C, and then turn it back on. Okay, so in the first one, and all the other ones, when you sketch the triangle, always have your angle, your provided angle when it's a side angle situation in the same spot. Okay, it'll make it more efficient for you to actually do future problems. Okay, now remember, this is angle B. How do I know that this is opposite it? Is because it's got a lowercase b. So angle A, I'm going to put into this, or not angle A, but side A, I'm going to put in that position. Okay, so my side B, which is 3, isn't quite going to make the base side of the triangle. And what I'm saying is it's not going to reach this. So because it won't reach it, it's 3, and remember this is an obtuse, okay, where B is much less than A in this case, and I go to the obtuse situation and I follow along and B is smaller, it's going to be no triangle. Okay, but I can't have you have this summary there all the time, but I want you to reason it as we go through. Okay, so this is not a no triangle made. Okay, in this next one, I'm still going to put B in that left corner. Okay, so I've got B's 56 degrees. It doesn't have to be perfect. It's a sketch. And I've got B being 11.5. So I've got 11.5. And A again, this is B. This is my lowercase b because lowercase b is always opposite capital B. And this is my A, and this would be also my capital A. And then I got C, and this would be my lowercase c when I'm doing the problems. Okay, and for that same reason, I've got my A and I've got C up there as well. But now keep in mind, I'm here to determine whether it's one triangle or two triangles. When I've got an acute situation and B is much larger than A, it's just one triangle. And that's what I'm here to determine, okay? Whether it's one triangle or two triangles, okay? Now, I'm always asked on this one, why can't it be a second triangle? Keep in mind, since this is much larger, it doesn't even have to be much larger. It's just larger. This is larger than that. And because it's bigger, it's not going to fit in there to be a second triangle, okay? So that's why it's just the one triangle. And this next one in B, or C, excuse me. I got B is 36. Opposite of B is 7. Now, I'm coming down here, I've got a 7. And this is a 12. That's my A, this is my B. I'm not quite sure if it's one triangle or two because that B is smaller, okay, than my A provided. Okay, the A is 12 and the B is 7. So I'm going to use the idea of making it a right triangle, okay? I just want to make sure it is a right triangle, or at least looks like it. I'm going to find H, okay, that height. And remember, as a right triangle, this is opposite hypotenuse now, if that's going to be a height as a right triangle. And I'm going to determine whether this H, this green H, is the same length as 7, bigger than 7, or smaller than 7. And then we'll hypothesize whether it's one triangle, two triangles, or no triangles. Okay, so I'm able to do that. That's opposite hypotenuse. Well, gee, sine of 36 is equal to my opposite. And unfortunately, h over 12, h being height, maybe perhaps I've got to come up with a better letter. But now I've got 12 sine of 36, which is h. Well, that becomes, I believe, 7.05 as we look through this. Okay, 0534, 7.0534. Okay, I just determined that height, h, is 7.0534. What do I know about that green h and that my side B? Which one's bigger? Well, it's my green h, right? Because the height at that point is longer than the side provided, it won't make a triangle. Does that make sense? So I have no triangle created here. So no triangle. Because that's 7. If it were longer than 7.05, I might have two triangles. If it was exactly 7.0534, I'd have one triangle. But in this case, because it's less than it, well, it's not going to reach the bottom. Okay, it's like a little kid trying to reach cookie jars. Ain't going to happen. okay, unless they make an adjustment. Get a taller friend or a chair, okay? So neither one of those situations is a possibility. So we're going to move on, and we're going to do D, E, and F, okay? Now, I know some did, some didn't, but I'm going to give you time right now to do D, E, and F. Go ahead. Okay, so here's the deal about D. If I look at this, and I got my 45-degree angle popped in there, and I'm going to try to, before I even start, I'm going to slow it down a little bit. So I got 45 degrees. That's my B. This is supposed to be 6. Maybe I'll put it in solid. Okay, this is 7. Now, the first thing I've got to do is determine, is 6 long enough? Okay, maybe it doesn't make a triangle. Okay, so I got to be thinking what that value is, and that's the height. So I'm going to use sine of 45. Remember, sine of 45 is the square root of 2 over 2. Okay, so I got sine of 45 is equal to H7. So I got 3.5 the square root of 2 here, but I'm going to slow that down. Pop that in my calculator, and I'm going to find out that that height's 4.950. So what we've just determined is that there is space over here for a second triangle. Okay, this is a 2-triangle situation. And so this is the one that's kind of ambiguous, and this is the one you really have to check. When you're given a B value and the side opposite it is smaller than the A value, and you've determined that it's going to make a triangle because this 6 is longer than the height, okay? And it's longer, not the same, because if it was the same, it would be a right triangle, okay? This is longer than the height. So now I've got 2 situations. By the way, both of these would be 6. And incidentally, do you remember isosceles triangle theorem? That the sides opposite the angles, if they're congruent, then the base angles are congruent as well. So this angle and this angle are congruent, okay, in this situation. We're going to use that. So I've determined on this one that there are 2 triangles that I will have to find pieces of. So I won't be just finding 3 pieces, I'll be finding 6. 3 on the bigger triangle and 3 on the smaller one. And I'll just keep that as my practice each time I do it. Okay. Now, in this next one, I've got an obtuse triangle. And let's at least have it be an obtuse triangle. It might be 10 degrees, maybe, if this is 170. Okay. B is supposed to be 52, and this is 39. Okay. It's going to be one triangle because 39 is that side A. This is my C. This is my A. This is my B. Okay. So this is going to be one triangle situation, according to not only my table and summary, but the things that I've done so far. Okay, is it making sense, that connection? Okay, now in this last one, I don't have A, B, and C the way we did, or excuse me, A in the angle B in the side B, the way we did. So keep in mind, I'm giving you A, which is 55, so that's the provided angle. I'm going to do it in the same pattern I did before. Okay, the provided angle is 55 degrees. Okay, the side A is 3.8. So this is 3.8, supposedly. Okay, and maybe I should put it out here just to see what will happen. Okay, this is 3.8. Will it be a triangle? And then this is side C, 4.6. So I really got to work in this situation. Again, this is smaller than this. If this was much larger, if the 3.8 was much larger than this provided side, then I'd be totally saying it's one triangle. Okay, but because it's smaller, it's this situation I have to check. Okay, so I have to check that the H. So again, sine of 55 is equal to H over 4.6. So 4.6 sine of 55 is equal to H. And crunching some numbers, you get 3.6. So this is 3.6. So that means I'm going to have, maybe I can clean up my little stuff there. I'm going to have a second triangle I'm going to have a second triangle if I don't like get rid of it. Let's flip-flop those things, okay? If I'm going to have a second triangle, and that's going to be 3.8 as well. Okay, yes, sir. 4.5 times sine of 55, or 3.8, excuse. That's 4.6 sine of 55. 3.768. 3.768. So it still might be, it still would be 2 if it's 3.768 because we can still get it in there. Okay, does that make sense? So that was my fat fingeritis thing. So it's 3.768. Everybody else okay with that? Okay, thank you guys. Thanks for doing that. Thanks for calling me on it, Joey. 3.768. But since that's still smaller than 3.8, I still have 3.8 on either side to deal with. Okay, yeah. If which one's bigger, the green? If the height is bigger than the side provided, it's not reaching to the bottom. It won't make a triangle at all. Does that make sense? Okay. Yeah. Okay, so remember this is a side-side angle situation. And every time I've got it, I'm always going to put the angle and then put the sides. Well, because they gave me that 4.6 is C, I just want to make sure that my A and my A are opposite each other, because this is okay for this to be C and this to be B. It's just the situation when I'm provided an angle and the two sides, okay? And what side is opposite the angle provided, how big is that angle, and then I go through that check. That's the thing that I wanted to make sure that you guys felt comfortable with, being able to say, hey, it's 0, 1, and 2 on those first 5, and then I'm not going to be able to give them, well, they didn't give me that B angle the way it's supposed to be, okay? So we got to start extending our knowledge about those beyond. Is that okay? Right? Any other questions on this? And thanks for calling me on my numbers, Joey. Okay, so in this case, it's still two triangles, since this is bigger than that height, okay? So now, how do I use this in the actual problems when I'm dealing with this stuff? Okay, now, on this next side, when we're going through, we might have time to do this, all right. So I'm looking at this idea. I'm given A. I've got 6 and I got 7. Now, the 7 opposite the angle provided is bigger than A, okay? Because of that situation, I know I just have one triangle to deal with. Does that help with that? Because it's much larger. So now I'm going to use the information that I had, and I'm going to find the missing pieces. My missing pieces I must find are going to be angle C, side C, and angle B. Okay, the first one I'm going to do is angle B. Okay, so if I'm going to find angle B, and I'm going to say measure of angle B here, measure of angle B. Okay, so in order to do that, I'm going to have my sine of B on top, my side B, which I know is 6, and I've got sine of A, and I like using the values that are already provided to me. I don't want to use values I find unless I absolutely have to, because fat fingeritis and my mistakes possibility, okay? I don't want to find something correctly on a mistake because it'll be wrong. So I've got the sine of B I'm looking for. And remember, multiply by B all the way through, so B will cancel on the left, but B will be on the right, up with the sine of A. And this is pretty much what my formula is going to be for this. Okay, I'm going to pop in my numbers. So I've got sine of B, that's what I'm looking for, and eventually I'm going to take the inverse sine. So the measure of angle B is the same as the inverse sine, okay, of B. I'm just going to put the number in. B is actually 6. Sine of A was 26.3. Okay, close out those parentheses, folks. And then on the bottom, I just got A, which is 6. Excuse me, I lied. 7. And I'll pop that in my calculator so I can do this. But be careful, practice this a couple times. Pay attention to your parentheses as you do this. Okay. So my measure of angle B in my calculator should shoot out 22.320 after I round. So check yours, make sure you're comfortable with it. Okay. Now, after I find my measure of angle B, I'm going to go for C. C will be easier. Because remember, the measure of angle C, finding C, is the measure of angle C is going to be the difference of the other two angles from 180. So I'm going to take my 26.3 I was provided and reluctantly add in 22.320, the value I just found, to find that my measure of angle C is 131.380. Okay? Measure of angle C. Okay? Now I've got 2 out of 3 pieces of my triangle I have found. Okay? I'm going to go for my third piece, and it's length of C, or side C. Side C. Okay, in order to do that, I want to do the reciprocal of the law of sines. So I'm going to start with C over sine of C. And I'm going to stay with A over sine of A because that's been a good number for me. I'm going to look for C. And I've got A, which is 7. The sine of C, which is 131.380, there, divided by the sine of A, which is 26.3, to find my value of C. And it should be 11.854. As I step through. Questions as we let it flow over. Making sense? Now there's 2 examples left. One I'm going to do where we have the opportunity to work with 2 triangles in the situation. Okay, so keep that in mind. We'll have a 2 triangle situation as we go through. Okay, and I even provide it. Now, be advised, on the test, you won't be given the opportunity to see, oh, you got to do 2. You won't be given enough blanks to figure out that you got to find 5 things or 3 things. Okay, you have to know that based on the information provided here. Okay, so when we're doing this, the situation must exist that it's an acute triangle, the side opposite the provided angle, smaller than the other side that's adjacent to that angle. Okay, and it reaches the bottom, meaning the height is smaller than the side opposite the provided angle. Okay, because otherwise it's no triangle, and you know, I don't have to do any calculations, right? So in the first one, what I'd like you guys all to do, it's your opportunity to practice finding C and B and angle C. Okay, so I want you to find those 3 pieces of the left triangle. Okay, and we're going to use those to help us find the pieces of the right, but find the missing pieces of the left one first. Okay, go ahead. Okay, I don't want to rush you. If you got them, just look up, check on me, all right? Make sure, you know, things are going okay. But it's helpful to get all the pieces of the first triangle, and we're going to use them to help us with the second. How will we know we have a 2 triangle situation? First, it'll be an acute triangle, okay? That'll be acute. This value is smaller than that value, okay? And it will actually make a triangle because this value here will be more than the height. It has to be more than the height. So let's check that off the bat. What's really nice, this is a 30, 60, 90 if I look at a right triangle. So it's a quickie. Half of 7 across from this would be 3.5 for that height. So it's like I'm cheating that I recognize that for my right triangle. But right now I know that that's 3.5 and I'm pretty darn happy about going on with it. Okay. Now, remember that's out of a right triangle, so that's how I know that this is going to be a 6 and that's going to be a 6. But I'm not going to worry about that smaller triangle in this particular problem. So my height is equal to 3.5. It's going to make two triangles. We're moving on. So finding B. Okay, I got sine of B over B, and I'm going to use A because they gave me that. So I've got sine of 30 over 6. Okay, so I suppose I should have put B as 7. So we're going to do that right away too. Okay, so sine of B is equal to 7 sine of 30 over 6. And I'm going to put it in my calculator as the inverse. So I can quickly find it, and that will drop that out, and I'll have the measure of angle B, which should shoot out a 35.685. Questions about that? Are we okay with finding B? Okay, now the next thing is finding C, which is B a lot quicker now because we found B and we got A. And finding C is measure of angle C is equal to 180 minus my A, which is 30, plus my B, 35.685. Okay, so my measure of angle C becomes 114.315 degrees. So I got C, and I've got B. Now, are there any questions about those two values? Feeling comfortable with them? Okay, now my last one was finding C, side C, as I go through this. So finding side C, remember the reciprocal of my inverse function, not the inverse function of my lost sines, I don't know what I'm talking about there. Okay, it's equal to A over sine of A. Okay, now remember sine of A was, capital A is 30, and the small a is 6, and I'm going to put in C, and I'm multiplying by the sine of C across, so my C was 114, so I'm going to have A, which is 6, that's 6, and I'm going to put in my sine of 114.315, that's my sine of C, I multiplied by sine of C on both sides, all over sine of 30, because that's my A, angle value. Okay, now once I do that, pop it in my calculator, and C will come out as 10.935. Now, I'm going to do something because I know some stuff about this. That's C1 because that's the longer C. In my next picture, it's going to be the smaller C, and I want to be clear about which value is which. Are you okay with those three values first before we move on? Now, remember that base angle thing with isosceles triangles? I know that since this is measure of angle B and that is 35.685, so is this 35.685. Now, I want to be clear about this, that they're supplementary to each other, the measure of angle ABC and this value here. So we got to keep that in mind as we're going through these, that I'm going to use this to help me with this next piece. I've got the measure of angle ABC is equal to 180. Mr. Janan, stop messing with my mouse. 685, okay? And I've got that going on, and I'm looking at the idea that the measure of angle ABC here is going to be, and I'm finding this angle right in here, 144.314. And that's my measure of angle ABC. Any questions on how I determined it? Okay. Yeah. Wait, on the start? On the left side here, I'm just looking at, I'm going to make that determination. It's not going to, they're not going to tell me in the problem, hey, you're going to find this stuff in this one triangle. You're going to find this information. You're going to determine the height. And in this one, we were able to do it really short because of 30, 60, 90 triangle relationships. And we're going to look at that and go, hey, there are two triangles here. Okay, so you're going to do the first one and use the information of the first one to help us with the second. Okay, so now I can find the measure of angle C, pop that in, because I've got B and A. I'm going to subtract those and find that my measure of angle C is going to be 5.685. But we will, finding C, and we'll probably have to find the rest tomorrow, okay? Because we're going to subtract that from 144.314 plus 30. And that shoots out as a 5.685 degrees. Okay, does that make sense as we go through? And we'll finish up at this part tomorrow. Thanks, guys, for your time. Okay, so we're going to find C now, finding C, and find side C. Finding side C, we're going to be doing the reciprocal of the law of sines and able to make this work. So we have C sine of C equals 6. Let's go A sine of A. Okay, so keep that in mind. Those are the things I'm using. That's the relationship. And when I multiply both sides by sine of C, I will get this. So now I'm just going to pop things in. A is 6. C, angle C, is 5.685 degrees. And A, capital A, degrees is 30. Well, when I pop those in, I'm going to find out that actually side length C, and this is C2, is 1.189. Okay, and that's our final piece of information we needed to find for example 3. I hope you guys have a great evening, and I sincerely hope that the assignment goes well for you at Schoology. Have yourself a great day.